All right, let's jump right in. Today, we're tackling a genuine cosmic mystery. I'm talking about a gravitational anomaly, something so powerful it's literally pulling our entire galaxy and hundreds of thousands of others towards it. But here's the crazy part. For decades, we had no idea what it was because we couldn't even see it.
So the question is pretty straightforward. Where is our galaxy going? But, the answer? It opens up this cosmic puzzle on a scale that is just mind-boggling. It's not just our Milky Way, it's every other galaxy in our home supercluster, a structure beautifully named Lambda, which means immeasurable heaven. All of us are getting pulled in the exact same direction.
And listen, we are not just kind of drifting along. We're hurling through space at a staggering 600 kilometers per second. That's over 1,000,000 miles an hour. And we're headed toward this one mysterious point in the constellation Centaurus. Now, this is not the normal gentle expansion of the universe we always talk about. Nope, this is a targeted pull. It's like a cosmic current that's dragging us somewhere very specific.
So this extra motion, the part that's separate from the universe's overall expansion, what astronomers call the Hubble flow, this has a name. It's called peculiar velocity. And what it tells us is that something huge has enough gravitational muscle to fight against the expansion of space itself and win. So the big question is, what on earth could be that massive?
Well, astronomers gave this mystery a name that's pretty hard to top, the Great Attractor. And for decades, figuring out what it actually is has been one of the absolute biggest puzzles in cosmology. A huge part of the problem, and this is wild, is that the prime suspect is basically hiding right in front of us. The reason we can't see it directly is because it's located right behind what's called the zone of avoidance, and that's just a fancy name for the middle of our own galaxy. The bright, dense, dusty plane of the Milky Way. It completely blocks our view, like trying to see through a thick, bright fog. So yeah, how do you study a cosmic monster that's completely invisible to you? Okay, when you run into a mystery this big, it forces you to step back and ask a really fundamental question. What if the problem isn't the Great Attractor itself? What if the problem is our understanding of the universe? A few physicists are suggesting exactly that, proposing a totally radical new way of looking at the fabric of the cosmos. So here's the breakdown. On one hand, you've got our standard model of cosmology. It works pretty well for the most part, but it has these two giant, mysterious placeholders called dark matter and dark energy. Then, on the other hand, you have this speculative but really fascinating new idea called PSUMO, and it proposes a radical simplification. It asks, what if the universe isn't mostly empty space at all? What if it's completely filled with a single, unified quantum superfluid? In this new picture, what we've been calling dark energy isn't some weird separate force. It's just the macroscopic flow of this cosmic superfluid. Think of it like a universal river current, flowing outward and carrying everything along with it. It's not a separate thing, it's the fundamental motion of the universe itself.
And what about gravity? Well, in this model, gravity isn't a fundamental force pulling things together. It's actually an emergent effect. It's the drag that's created whenever matter, like stars and galaxies, gets in the way of that universal flow. So matter doesn't pull things from a distance. Instead, it creates a disturbance, like a wake or an eddy in the current. And it's the pressure of the surrounding fluid that pushes things together into that low-pressure zone.
Okay, so let's pause for a second. We've got these new rules, right? A universe that's a flowing superfluid, and gravity is just drag. With that in mind, let's circle back to our original cosmic mystery. How does the Great Attractor fit into this wild new picture? The best way to get your head around this is with a simple analogy, one that's right at the heart of this idea. Let's imagine the universe isn't a big empty box, but instead, it's a vast flowing river. And if the universe is a river, then the Great Attractor is its sinkhole. See? It's not some mysterious object with magical pulling powers. It's a colossal sinkhole, a point of immense drag, where that natural outward flow of the universe is being disrupted and channeled inward, dragging us and everything else nearby right along with it. And this is where this new theory starts to sound really compelling, because suddenly, the Great Attractor doesn't look like an anomaly at all. This large-scale streaming motion of galaxies, this dark flow, is exactly what the PSUMOT framework would predict. It's precisely what should happen around a massive object acting like a cosmic sinkhole. The observations seem to fit the prediction like a glove. So that leads to the big question, right? Does this mean the theory is actually correct?
It sounds like a verified prediction, doesn't it? I mean, on the surface, it really looks like it. The great attractor seems to be a perfect, almost textbook example of what this new model predicts. But we have to be careful. It's a perfect conceptual fit, as elegant as it is, enough to call something hard science? Is it really a verified prediction?
And this is where we hit the brakes and talk about the crucial difference between a really good story and a scientific theory. Right now, PSUMOT gives us this beautiful, elegant explanation that perfectly accounts for mysteries like the great attractor. But science demands more than just a good narrative. It needs hard numbers. It needs rigorous mathematics. And crucially, it needs to make unique predictions that can be tested and potentially proven wrong.
So, just to be crystal clear, this framework, PSUMOT, is not a proven scientific theory. Not yet. The best way to describe it right now is as a sophisticated theoretical construct. It's a really compelling idea with a fantastic narrative, but now it has to face the music. It has to go through the gauntlet of rigorous scientific validation. And the path forward is actually pretty clear-cut. First, those analogies, the river or the sinkhole, they have to be replaced with rigorous mathematical models, probably based on something called quantum hydrodynamics. Second, from those models, you have to derive specific numerical predictions. And third, and this is the most important part, it has to predict some unique, falsifiable signatures. Specific signals in the cosmos, maybe weird gravitational waves or imprints on the cosmic microwave background that only this model can explain. Things our new telescopes can either go out and find or rule out completely.
So, where does that leave us? Well, the great attractor doesn't prove this new theory, but its behavior aligns with it so perfectly that it acts like a giant cosmic signpost, and it's pointing us toward a question that is about as profound as it gets. Is our universe just a collection of objects floating in empty space, or is it a single, flowing, unified whole? And if it is, what does that mean for us? After all, we aren't just living in the universe, we would be part of its flow.